Yeah.
Okay, so.
And who is third?
Okay, perfect. Nice to meet you. What do you do with composting? I'm looking for it. That's the composting one. So, yeah, we're going to have
What do we want to
time? Of course, yeah, it's something
I will just keep like. Like a 5 minutes reminder, 2 minutes reminder, and then 1 minute reminder.
Is this for the 15 mark or?
Yeah.
Okay, we're good, yeah.
So once you get done, then I'll have 5 minutes to come questions from the audience and then the response to this. Okay, it's gonna be cool. Don't worry.
Awesome, thank you.
You're welcome.
Need that? Do you need that?
Yeah, that's what I look. I have mine. Let me get mine.
No. I'm just kidding. I'm just kidding. You just a minute.
No worries. So this like 3-year evaluation of knowledge. What is that? What is that? Region, what's the region? I don't even know.
You mean 2 years? Okay.
But
Interesting.
what is Legionella? I don't even know what's.
That's a pathogen.
Oh. We all
I mean, it's a bacteria.
So if the building is.
I think if you're taking shower, if it's like hot bath or something, then
There's a lady who is from ICRB who was hired to be a PhD in California, but she has several publications. She's like,
she was doing that.
she's from ICRB, and I looked at her and I'm like, oh my God, this lady was super. Okay, now this is the one we're starting with. We should do it.
You want to give this edit some setting up?
I only pronounced the first name and I stopped there. Okay. Hello, everyone. Can you hear me? So thank you so much for showing up for this session. My name is Dr. Musa Manga, and I'm faculty at University of North Carolina, Chapel Hill. I'm basically interested in sanitation, and that's the reason I'm moderating this session. And we're going to have 3 presenters today talking to us about different aspects of their research. And in most cases, I will try to keep time. So I want us to start on time. So I'll start by inviting the first presenter, who will use 15 minutes presenting and 5 minutes Q&A. And that would be Alison from Emory University, who'll be talking about evaluation of an innovative nature-based approach to decentralized wastewater treatment in urban informal settlements. Welcome, Alison.
Hi, I'm Allison Salinger. I'm from Emory University, but I'll be presenting today on behalf of the RISE trial. Just a quick note before I jump in. As you can see, I have a number of co-authors. Some of them are engineers and microbiologists. I am neither of those things, so I will do my very best to answer your questions at the end, but if I'm not able to, I'll be happy to connect you with any of my co-authors, one of whom is in the room taking pictures of me, so hopefully she can help answer some questions as well. So today there are 1 billion people living in urban informal settlements worldwide. And that figure is expected to increase to 3 billion by the year 2050. By definition, informal settlements lack access to basic services like water and sanitation and are often situated in hazardous environments, making it difficult to connect residents of informal settlements to conventional reticulated water and sanitation systems. For that reason, RISE takes a water-sensitive cities approach to provide site-specific solutions for water and sanitation. The water-sensitive cities approach combines conventional engineering approaches or gray infrastructure with nature-based solutions or green infrastructure. And the approach has been successfully implemented in places like Australia, Singapore, China, but evidence from low resource settings and certainly from informal settlements is scarce. RISE also uses tried and true smart technologies, namely the pressure sewer depicted here, to help implement the nature-based solutions in these unique low-lying informal settlement environments. The intervention has been randomized to 24 urban informal settlements in Suva, Fiji, and Makassar, Indonesia. Plus, we have 1 demonstration site in each country. So today we'll focus on some preliminary findings from our pilot site in Indonesia, which was intentionally small scale with 12 households and 58 people. I also have here a couple of publications that are open access available for your readership, our protocol paper and the baseline paper from Indonesia. I'd be happy to share links afterwards. So using the water-sensitive cities design concepts and input from extensive participatory design activities with residents, the intervention included solutions for water in the form of a rainwater tank for each household to supplement non-potable water supply. And RISE also played an advocacy role in getting households connected to the municipal drinking water supply. In terms of black water management, for those households that needed it, there was provision of bathroom upgrades or new bathrooms. And for all households, there were connections from toilets to the pressure sewer, which was necessary to move sewage up to the septic tank. From this point onwards in the treatment train, everything happens under gravity flow. But the septic tank provides primary treatment, subsurface wetland provides secondary treatment, and then surface wetland provides tertiary treatment before effluent is discharged into the canal. In terms of gray water management, all households were provided a biofilter that filtered water from kitchen, laundry, and bathing activities before that water was discharged into the stormwater drain. And for drainage and flooding prevention, there were flood walls constructed to prevent contaminated runoff from draining into the site, which was especially important in this demonstration site as it is located at one of the lowest points in the larger catchment area. And this is true for a number of our study sites. And in addition, an elevated road was constructed to provide flood-safe access to all households. And the road also sort of houses that black water treatment train and the stormwater drain. So ongoing monitoring of the pilot site has allowed us to begin to answer a few key questions. And I'll really focus in today on the sanitation-related intervention components. So, of course, we want to know about treatment efficacy. In a steady state, can that black water treatment system meet national standards for effluent water discharge? In terms of cost effectiveness, how do the construction costs of the demonstration site compare to conventional wastewater treatment systems in Indonesia? And then in terms of acceptability, we used a qualitative approach. So from the residents' own perspectives, what were the benefits and consequences of the intervention? In order to assess treatment efficacy, the team in Indonesia collected 116 samples from 4 locations in the treatment train that are indicated in the blue arrows here. Sampling is ongoing, but we're presenting data today from the period May to November 2021, and we feel that this is representative of a relatively steady state in the system. So what you're looking at here is median contamination levels for a number of parameters at each of those 4 locations in the treatment train that were indicated with the blue arrows in the previous slide, compared to the Indonesian guidelines for domestic water discharge. And then we've also included % reduction from contamination levels at the septic tank, which we're calling the sort of inlet of the black water treatment system, to the end of the surface wetlands. So as we can see, pH and oil and grease were below national guidelines at inlet and outlet, so no problems there. E. coli, BOD, COD, and TSS were high in inlet, low in outlet. So we see this high load reduction, and they're meeting national guidelines in the effluent. For ammonia and total coliforms, we do see a high load reduction from inlet to outlet, but effluent is not meeting national guidelines. For ammonia, it's not necessarily surprising to see high ammonia concentrations in a black water only system. That's pretty standard, and that's what we're dealing with here. However, since analyzing these results, our team in Indonesia has been trialing some solutions to incorporate additional aeration along the treatment train, which I'm told will reduce the ammonia in the effluent. In terms of total coliforms, we see that from the septic tank to the subsurface wetlands outlet, there is a reduction in concentration. And then from the subsurface wetlands outlet to the surface wetlands, we see it spike again. And so what this indicates to us is that there's some natural growth of coliforms occurring in the wetland environment. And that suggests that these aren't necessarily fecally derived coliforms. But of course, we want to be sure, we want to test that hypothesis. So our team in Indonesia in response has incorporated a measure to test fecal coliforms specifically. We've started collecting that data, and we'll track fecal coliforms compared to total coliforms at each of these points in the treatment train and over time. In terms of cost, so we're comparing actual costs of construction of the demonstration site to estimated costs for a comparison project in another city in Indonesia. And this was the construction of a wastewater treatment plant plus connections for 12,000 households to that wastewater treatment plant. If we look at the bottom row in the table, we can see that the overall cost per household was lower for the demonstration site than for the comparison project. And the demonstration site offers these additional co-benefits in the form of drainage and flooding prevention and some degree of water supply. In order to understand more about residents' perceived benefits and consequences, we conducted in-depth interviews targeting 1 member per household balanced on gender. We heard from women that they enjoyed improved cleanliness and privacy due to bathroom upgrades and beautification of the settlement from the flowers and plants in the constructed wetlands. Unfortunately, we only heard from 1 male resident that reduced exposure to contamination or pollution, as he called it, was perceived as a benefit of the sanitation-related components of the intervention. We also heard from a number of residents that there was intermittent odor from the wastewater system, but action has been taken in response to these findings and some earlier reports, and ongoing monitoring suggests that the odor has been eliminated. Interestingly, when we ask residents about perceived benefits of the intervention overall, what we heard about the most by far was the road. So I'll present some of our qualitative findings around benefits of the road as well. So of course, residents said that the elevated road helped avoid floodwaters during rainfall. And it also improved access to the settlement, making it easier to get to school, work, or the market, and to transport construction materials, which residents said they were using for housing improvements. There were also benefits for women's time use because women could get out of the settlement to get to the market. And for the first time ever, vendors were able to come into the community to sell their goods. The road also provided a place for neighbors to meet, both formally and informally. Residents said that before the road was constructed, even just to chit chat with your neighbor, if you set your chair out in front of your house, the legs of the chair would sink into the mud. And so this was a way to meet both formally and informally. Other components of the drainage and flooding prevention piece of the intervention, of course, helped reduce frequency and severity of flooding. That's from the residents themselves. However, they did say that during major flooding events, the road would still become inundated, but that it was trafficable at that time. Some, although few, residents also raised concerns for the future about potential safety and security because of increased access due to the road. So we see that decentralized nature-based solutions can be used for wastewater treatment effectively, cost efficiently, and appropriately in urban informal settlements. We would make recommendations, however, for local authorities to create standards specific to nature-based solutions. This is not a suggestion to lower standards, but rather to ensure that treatment effects are not obscured by using inappropriate parameters intended for traditional wastewater treatment plants. The qualitative data also demonstrates how the site-specific participatory approach helps to identify and respond to resident needs that emerged during implementation, such as the need for improved access, in tandem with program objectives, like the need to reduce exposure to contaminated floodwater. We're hopeful that this approach will promote ownership and sustainability of the intervention moving forward. I'd like to thank all of our partners on RISE and would be happy to take your questions.
Right, thank you so much for that great presentation. I think we can receive kind of general questions from the audience about
Great, Kellogg Schwab, Johns Hopkins. This is cool, you know, it's the integrated approach in there and all that. But these are informal settlements, and so was there a discussion with the community and also I know it's the government's on like road construction. I mean, that's a pretty impressive approach to something where it's historically only been looking at one aspect of it, you know, either sanitation or drinking water. So was there a reflection on that? That's, you know, how does this go forward to scale in informal settlements if you're now constructing more established roads and things like that? Was there kind of an ownership discussion on access and roads in general? I'm just curious.
Yeah, that's a great question. There was early on, the program had workshops with the community and the city to talk about operation and maintenance of the intervention, you know, once the RCT is gone, and who is best tasked with each sort of piece of that. And so, yeah, absolutely. The government has committed to operation and maintenance of some of the more technical aspects, whereas the residents themselves have taken responsibility for operation and maintenance of you know, the septic tank, the wetlands, things like that, that really require you being like in the community day to day. Yeah, to the point that in December of this year, some of the senior representatives of the city of Makassar are headed to Melbourne, Australia for additional systems training so that that handover can run smoothly. Yeah.
Great. I got another one. But jump up. So it was interesting in that treatment stream, you actually had to go up gradient. So there's power required for that. Was it a I mean, how was that integrated into the cost of like having to move, you know, water's heavy, so pushing it up for a non-potable use, so to speak, was that part of the consideration? I know it sounds like there was no other option if they're at the bottom there, but
Yeah.
how did that get folded into this kind of overall who's taking care of it and pumps break and power and issues like that?
Yeah, so the pressure tank is to move sewage up to the septic tank. And it, yes, does use electricity, and ultimately the residents will be responsible for the ongoing costs to run the pump. There are a certain number of households per pump. And so they are arranged in clusters so that they can cost share that electricity cost. And in the pressure sewer is certainly the engineers would call it like the Achilles heel of the system. And that is something that we've made really sure that the government is taking responsibility for operation and maintenance of, and has received extensive training on.
Great, thanks.
Right, thank you so much. Do we have any other questions from the audience? Yes.
Yeah, thank you so much for here and also I'm a big I have two questions and this one related to the very first question. So these are informal settlements. So I'm surprised in a good way that the government committed to this project or to this infrastructure. What was your experience with the government? Why do you think that they participated? And then my second question is related to space. Because normally I can when we think about urban settlement, it's very dense and empty populated. So that doesn't seem to be the case here. Or if you were to upscale that, how would you manage that?
Yeah. Okay, I'll answer your second question, then might ask you to repeat the first one. So in terms of space, yes, that was part of the rationale behind having it be a black water only system and have the gray water be handled separately, because the volume of water would have required a much longer wetland in order to treat effectively. So we prioritized the most contaminated water, which allowed us to reduce the space required for the black water treatment train, the wetland. There's also, in this small scale community, there's one wetland. As we scale up to some of the larger communities, the design would be for clusters of households to share a few different wetlands. And yeah, finding space that was a big part of the extensive participatory approach, was locating this shared infrastructure within the community and making sure that it was in a place that everyone was comfortable with. Repeat your first question, sorry. Oh, yeah. Yeah. Yeah, I personally have not, that hasn't been my role in the project. So I would be happy to connect you with someone who has had, an extensive part in working with government. I will say, I know that in certain communities, the program played an advocacy role in getting the government to first recognize the informal settlement sort of as a community that has these needs that exist. And so that offered some sort of weight on the government's shoulders, and also alleviated some of the fear of eviction on the part of the residents, making them more willing to sort of really play an active role in contributing to this.
Right, thank you so much for that. The problem of being a moderator, but I'm limited asking the questions. So the topic she's talking about is one of the topic I'm very interested in. And I had a lot of, several kind of questions for you, but in the interest of time, I'll probably pose them. But really surprised with the informal settlement you presented, because several informal settlements don't have access roads that you could actually upgrade like that. 2, they don't have space to have such a system. 3, most of them, they are living below the poverty line. So they cannot afford to share kind of cost for energy and all that. And then when it comes to the technical bit of systems, I've worked in septic tanks for the last 10 years. kind of performance is, what's the sampling frequency? When did you sample? You know, there are quite a lot of things to look into that, but I'm not supposed to ask questions because I'm the moderator. Can we have this second presenter? And that would be. Okay, so let's have the second presenter, and that's going to be Monica, who's coming from Johns Hopkins, that's going to explain, talk to us about some interesting research about assessing multiple water supply treatment approaches. Monica, you're welcome.
Perfect. All right, good afternoon, everyone. My name is Monica Lee Massey, and I'll be presenting on the 2-year evaluation of Legionella in an aging residential building, looking at assessment of multiple water treatment approaches. A brief introduction about Legionella. Legionella bacteria is a waterborne pathogen that is ubiquitous in water systems. The main ways of exposure of Legionella is through aerosolized droplets that are formed from showers, fountains, humidifiers, and cooling towers. Legionella has been known to cause Legionnaire's disease, which can be contracted by the inhalation of Legionella in aerosolized droplets that travel into the lungs. Once Legionella enters the respiratory pathway, this microorganism can cause acute lower respiratory infection. Legionella has a 10% case fatality rate and an even higher rate of 25% in healthcare facilities. In the most recent CDC waterborne disease outbreak annual surveillance report, Legionella is the leading cause of waterborne disease outbreaks. Of these outbreaks, Legionella has caused about 90% of hospitalizations and 100% of all waterborne outbreak associated deaths. In 2018, there were reported 10,000 cases of Legionnaire's disease, but the true number is actually estimated to be 1.8 to 2.7, higher than that due to underreporting. In the US, Legionella is or legionellosis is a reportable disease. However, there are no standard or federal monitoring for Legionella in the environment. This is a major problem because Legionella has been known to flourish within premise plumbing. So premise plumbing is referred to the pipes and plumbing systems in residences and buildings. When buildings and residences experience reduced water use, similar to that of the experience of the COVID-19 building shutdowns, many water quality issues arise. So stagnant water from reduced water use can cause the loss of free chlorine, which typically controls the microorganisms in your water. Stagnation can also decrease your hot water lines to temperatures that are optimal for bacterial growth. The water quality changes experienced from stagnation is really ideal for premise plumbing pathogens such as Legionella and allow them to grow within shower heads, faucets, and pipes. So once Legionella colonizes a premise plumbing system, they're really difficult to eradicate or remove. So in a collaborative partnership with our buildings managers in Maryland, we were able to assess these issues in a natural experiment that gave with unprecedented access to a residential building's water system. This natural experiment was conducted over the course of 2 years during both the COVID-19 shutdown and the building's reoccupancy. This building, which I will refer to as Building A, was shut down during the COVID-19 pandemic. This building is older than 50 years and had low use from March 2020 to December 2020, had partial reoccupancy in January 2021, and then full reoccupancy in September 2021. This building has four floors, a basement, floors 1, 2, and 3, and 3 risers, which I'll refer to as A, B, and C. The cold water enters from the drinking water distribution system from the basement in riser C. and then flows to riser B and then A. The water then rises up to the top floors and then flows downwards to the bottom floors. The hot water is heated in a 4,000 liter tank that is located in the basement riser B. This water is then enters a recirculating system that flows to each riser and then flows to the top floors and then flows downwards to the bottom floors. So during the 2-year assessment, the following approaches were conducted by operators in an effort to reduce Legionella growth in the building and prepare the building for reoccupancy. There were 3 single heat shock events where the hot water systems were heated to 65 degrees or 150 degrees Fahrenheit for 12 hours and then flushed from the system. Water elevated to these high temperatures has been known to eradicate or control for Legionella. There were 2 single chlorine dioxide treatments that were conducted in both the hot and cold water systems. Here, the water was treated with chlorine dioxide at 2.5 parts per million for 12 hours. Chlorine dioxide has been known to be very effective in reducing Legionella, even at lower residual levels, and has been known to break up biofilm that house and protect Legionella in the pipes. There was also 1 shock chlorine treatment that was conducted in both systems also at a higher concentration of 20 parts per million. And this was to further reduce Legionella concentrations in the water and reduce biofilm in the system. I do want to note that for all these treatments, there were no occupants to ensure the safety of the occupants themselves. Lastly, there was a continuous low-level chlorine dioxide treatment at 0.2 to 0.4 parts per million, which was implemented after the single treatments to ensure continuous Legionella treatment at safe levels while the building was occupied. So this natural experiment that addressed Legionella in real time has led us to our research question. Which treatment approaches can potentially reduce Legionella growth in an older building? Is it the single heat shock treatments, the single chemical shock disinfection, or the continuous low-level disinfection? The sampling strategy for building A consisted of collection of 1 liter samples from hot water lines at 12 showers with the shower heads removed. Also from cold water lines from the basement and 2 faucets with the aerators removed. We collected at time 0, which represented water at the outlet, and at time 5, which is represented water in the building pipes or after a 5-minute flush. We measured pH, temperature, and chlorine, free chlorine, and for later analysis, turbidity and total organic carbon. We collected 100 milliliters for Legionella pneumophila using IDEXX's most probable number culture assay. The results took a minimum of 7 days, and the results were also represented in MPNs per 100 milliliters. We also collected for 100 milliliters for molecular analysis to examine different Legionella species in samples. For the sampling size, there were 26 sampling events starting from August 2020 to March 2022, and we collected over 700 samples from both hot and cold water lines. Now I'm going to show you a heat map that is a representation of Legionella pneumophila from all sampling points. This heat map is represented in most probable number, MPNs per 100 mils for hot water locations. The y-axis here represents the shower locations by riser and by time 0 and time 5. The x-axis represents the sampling date. The legend shows the concentration of Legionella at different shades of red. So white representing no Legionella growth, and then increasing logarithmically from 1 to 9 MPNs per 100 milliliters to greater than 10,000. So the brighter the red, the higher the Legionella is present. Here is my heat map of all the sampling points. We see visually that there is greater Legionella present in riser A compared to B and C. And that over time, that this concentration varies by not only sampling event, but also by location. Now let's look at specific treatments of interest. A single heat shock was conducted on December 12th, 2020. And to compare the pre and post heat shock samples, we ran a paired t-test and found a p-value of 0.44, or indicating a non-statistically significant reduction of Legionella from this treatment. Comparing pre and post heat shocks 2 weeks later, we had a p-value of 0.12, also indicating no statistically significant reduction. But I do want to note that these numbers were very low to begin with. Now comparing the pre and post heat shock events samples from a heat shock event conducted on May 18th, 2021, we found a p-value of less than 0.001, indicating a significant reduction in Legionella. However, comparing the pre and post heat shock samples weeks later, the Legionella concentrations resumed back to pre-shock levels. So from these heat shocks, we found that there was statistically significant reduction days after. However, no statistically significant reduction weeks after treatment. Now we can move over to the single chemical treatments. So comparing the pre and post samples of the first chlorine dioxide treatment from July 30th, 2021, with the p-value less than 0.001, there was a statistically significant reduction in Legionella. Also comparing the pre and post from the second chlorine dioxide treatment conducted on August 11th, 2021, there was also statistically significant reduction even at low pre-treatment Legionella numbers. However, after the shock chlorination event in August 16th, 2021, there was actually a statistically significant increase in Legionella concentrations weeks after treatment. So from these single chemical treatments, we found that there was a statistically significant reduction days after treatment, but also a statistically significant increase in Legionella weeks afterwards. So because the single treatments were not effective long-term, the decision was made to evaluate a continuous treatment approach. The continuous chlorine dioxide treatment started on February 21st, 2022. Comparing the pre and post of the start of the continuous treatment with the p-value of less than 0.001, there was a statistically significant decrease in Legionella. However, weeks after the start, there was a statistically significant increase in Legionella, but these levels started to significantly reduce months afterwards. So again, this is a continuous application of chlorine dioxide in the system. So while there was an initial increase of Legionella concentration, that means the treatment just may have required weeks to months to actually experience a reduction in these concentrations. My main takeaways for this talk is that Legionella were consistently present and unevenly distributed in the hot water lines, and they were very difficult to remove in this highly colonized building. Single heat shocks were ineffective at both in short-term and long-term reduction of Legionella concentrations in hot water systems. And also single chemical disinfections that were can effectively reduce Legionella in both systems short-term, but saw regrowth weeks later or long-term. Finally, continuous low-level disinfections can effectively reduce culturable Legionella, but in the long term. In conclusion, Legionella is a complex, and pipe system is a very complex challenge. Heat shocks, flushing, and single chemical disinfections are not effective long-term to reduce Legionella. Continuous low-level disinfection can be effective long-term. However, this solution requires considerable cost, energy, and manpower. Other sources or other types of solutions include point-of-use remediation, such as filtered shower heads or disinfection of fixtures. Bottom line, every building needs a comprehensive water management plan that needs to be developed and implemented. And this is to ensure the safety of all building occupants. Here, I'd like to give my acknowledgements and funding sources. And thank you for listening.
Thank you so much. I think that's really great presentation. I think we'll get questions from the audience. Yes.
First, congrats on this work. every slide I was thinking to myself, oh my goodness, I don't want to know the result. I guess I'm thinking more about these like office buildings that have had these like such low use for basically a year or so, and like wondering, are those building managers aware of this issue? Like, are they gonna do these things to remediate the Legionella in these areas? Because there's so many buildings in this country and worldwide that have just not been used for so long. Just wondering what the awareness is, and also different exposure, because probably fewer showers in those office buildings and the residential buildings, but yeah, that's just. Right?
Yeah, great question. For the first part, they should, right? But it's, again, this is not, there's no environmental monitoring or there's no federal standard regulation for Legionella in drinking water in buildings and residences. So it's really difficult for not only to acknowledge this problem, it's also difficult to manage this problem and address this problem. Thankfully, organized agencies like the CDC, agencies like the AWWA, and then also EPA have established toolkits and guidelines on how to properly reopen buildings for using such as flushing or heat shocks. So hopefully that answers your question. Or did you have another part of, yeah. Yes, so that's the thing. These toolkits and established guidelines or guidances have recommended those types of solutions, but as you can see here, there's going to be the need for more extensive treatment.
Hi, I'm Melissa Frisco with USAID Bureau for Humanitarian Assistance. I don't know if this is on, but anyway, I'll speak loudly. Really interesting. I had no idea Legionella was so prevalent. Kind of shocking to see. And wondering if there's been a spike in cases. If you look post this, I mean, it is this perfect natural experiment, sadly. With so many buildings shut down, and I've had exposure is huge, especially knowing that the systems that have been in place, the guidance doesn't really work, and we've got a lot of old buildings in this country, not just this country, but around the world. So yeah.
Yeah, so there has been, again, random spikes in different parts of the country during summer 2021, where building reopening, where residents are, sorry, people entering buildings that have been reopened have contracted Legionnaire's disease, and this clinical or health professionals have kind of linked it to the reopening of these buildings not being properly managed.
Just to follow on that, so it sounds like the growth potential is massive in buildings that aren't going to be not now. I mean, we haven't had a situation like this. Is this catching hold your study? Because I think this is actually the first time I've heard something like this. Interested to see it kind of being broadcast.
It's, it's hard because, again, these symptoms for Legionnaire's disease mimic exactly the same thing for COVID-19. It's a lower acute respiratory infection, so they may be just being missed. They may, people who have actually caught Legionnaire's disease may have not been tested for it properly. So that's why it's not as advertised, because we're still in a pandemic.
Can I just talk real quick? We're not all dead. Realize that this is a problem for for the elderly population, but for many instances, the aerosolization and many factors have to occur before you get Legionella. So in cardiac fever is a mild one, which mimics flu, and then other symptoms in there, and people aren't testing for it. The challenge is outbreaks are investigated by the Centers for Prevention, and they do a good job on it. We're talking endemic evaluation, standby, we put in a bunch of proposals for it. We're getting where others are getting where too, by the way, but it's below the radar in there, and it should be higher.
So I'm wondering what kind of regulatory framework do you think would be helpful to address the situation? CDC, kind of public health guidance, but I can think maybe OSHA.
Yeah, definitely. Yeah, great question. Definitely OSHA, because again, the people who are in the front lines flushing this water have the most exposure. I think, again, New York has regulations for Legionella in drinking water, so following their guidance or their lead would be a really good first step. Yeah. And also, like my PI has said, that we do want to protect not only, the general public, but also the older susceptible populations that are more susceptible to Legionnaires.
All right, that was really great presentation. We shall have the last presenter, and that's going to be Patrick, who'll be talking about improving treatment of container-based sanitation via windrow composting in Haiti.
Great, thank you, everyone. My name is Patrick, and I'm here representing Soil. I'm here to talk to you guys about our improved windrow composting treatment techniques, but I also recognize that I'm the last stop before happy hour, so I'm going to try and make this enjoyable. But yeah, so before we get too far into this, I'd just like to recognize my colleague, Julie Jeliazowski, as well, who did a lot of this baseline research that I'm presenting on. So for starters, let's talk about who is Soil. For those of you who don't know what container-based sanitation is, I'm going to brief you on that, but then also what the problem is, what we did about it, and realistically, what are the next steps and why this matters to everybody in the room. And I know I said I'm going to tell you about it, but if this video works, David Attenborough is going to do it a lot better than I am. So here we go. And the video might not work. Yeah, so we're working on the subtitles right now. Yeah. Mhm. Great. So I don't have a great British accent, and we missed a lot of cool, catchy music. But this is kind of just a quick run through in case the video didn't work. We prepared for this. And I do want to focus on the waste treatment side of things. But if you guys have questions about container-based sanitation, there's a number of us in the room that would be happy to talk more about it. But the gist is waste to resource and treating a number of issues through sanitation and through container-based sanitation in particular. But so what is the issue at hand? So we currently want to scale up to 8,000 households in Cap-Haïtien, in the Cap-Haïtien region in northern Haiti. Right now we're serving about 2,000 households, and in our current process, we have a waste treatment site where we could continue this process and potentially scale up to over 3,000 households. And with each additional 120 homes, we would need more infrastructure and more bins, which I'll get into in a little bit. And I think you guys can see pretty clearly that there's an issue with size and how we're going to manage this. So diving into this, bin composting itself, we have these 12-meter cubed bins. They fit about 1,200 containers each. And the waste will sit in these bins for about 2 months. They'll hit certain temperature requirements to make sure that we're killing off pathogens. And then the bins are emptied, and the compost, or soon to be compost, is turned once a month until it's reached maturity. And all in all, takes about 6.5 months. We of course test for quality and E. coli and other safety measures, and then we sell it for our ultimate goal that you saw there at the end of the video, or at least read at the end of the video. So when we're looking at different options, we found that windrow composting is a viable solution for large-scale operations, at least for others before we're testing it. And so This process looks similar, but we dump the containers directly onto the ground. Let it sit for about 10 days, turn twice a week for a month, and then once a week until we've reached compost maturity. And the reason that we chose to do bin composting in the past is it worked at small scales. We could hit those requisite temperatures with the amount of waste that we were processing. And also the Ministry of the Environment asked that we not do the windrow composting or put waste on the ground until we could prove that leachate wasn't getting into the groundwater, which we have done since then. So we created this experiment. We had about 7 test piles between May of last year and February of this year. And within that date range, we have our bigger rainy season, cyclone season, some of our hottest months and some of our coldest months. So this captures some seasonality. We tested for maturity time, the amount of compost yielded, and the cost overall. And we ran these through a lot of similar processes that we would for any of our other composts. So testing for E. coli, temperature, pH, and in this particular test, we used geofabric or geotextile to preclude vectors and keep in humidity. And this is where it gets really exciting. So you'll see in the picture, we have a picture of one of our compost piles with the geofabric on the top. And more importantly, with our findings, we found that it takes less time, produces more compost, and it is more labor intensive, but it is less expensive overall, much more efficient, as you can see, and also much less infrastructure. And I'll dive into these results here in a second. So it looks like some things got a little bit out of line. But the orange represents the original process, the bin composting, and the green is what we have for our windrow test piles. So these safety and maturity requirements were met in less than 3 months, so cutting the time in half. And that was found to be very significant with a p-value of less than 0.001. Yeah. As far as compost yield, so another very significant p-value, over 10% from the orange bin composting line. And sorry, yeah, so you can see that even the lowest producing windrow pile is still at the average or above the average of our bin composting. And the cost, I know this is a number game for a lot of us, so let's talk about the cost. I'm gonna leave this up here for a little bit because it is a little bit more involved. You have the households on the bottom, households in service, and then the cost per household on the side per month. The orange line is again the bin composting. And for the numbers where we have 57% less expensive on the bottom, that's comparing it to manual windrow composting. And you can see that it is because of less infrastructure and increased efficiency, it is expected to be cheaper. But also there's this dream that I'm going to talk about in the next slide as well of mechanizing our process. So with bin composting, it was limited and we had not a lot of ability to mechanize our processes, but with the windrow composting, there is a possibility to incorporate different equipment and really improve our processes at about 3,000 households, a little bit less. So we're getting close to this number where we can really start to make some increased efficiencies. And so what that looks like is this is what I dream about, if you guys are curious. This is a giant windrow turner at a large scale composting process. And so maybe in the near future, we'll have something that looks a little bit like this. But so our next steps, we're already actively transitioning from our bin composting to the windrow composting. We're doing so in a phased approach that we don't have to disrupt any of our current services. We're still serving our customers right now. And hopefully scale up to 8,000 households pretty soon. And as we're doing this, we're looking at how can we improve our process. We turn it twice a week for a month and then we go to once a week, but what is really that ideal number? And like, how much can we water it? And what are these little things that we can change to make windrow composting as efficient as possible and really get those returns? And in addition to that, of course, ergonomics, taking care of our workers and making sure that they're going home happy and that we're also using the best equipment that we can to improve these processes. And the giant turning machine. And I think some of you have talked about soil throughout the past week, and you've seen some of our presentations. And we're always looking to diversify our waste to resource avenues. And so why this matters, and this is something that one of my colleagues mentioned to me when we're typing up the abstract, and truly captures what I love about soil so much. But we're finding these sanitation solutions that are holistic. They're systems thinking. We're thinking about the environment, but also I think the biggest thing for me is equity and why this matters to everybody else. Yeah, and it's low cost, and I think this is not only just a great solution in the context of Northern Haiti and working in humid Caribbean environments, but also, you know, I did grad school in Colorado and we don't have a lot of water there. And like, why don't we do these things otherwise? This is a technology and a technique that I think could truly be implemented anywhere. And I do believe that. So I just want to give a shout out to the soil team who is working even as we know that Haiti is going through some challenging times right now and just pulling off great feats in sanitation. And they make this work so enjoyable. I hope you guys noticed that the compost team in the very first slide, I forgot to point that out, but they're really the oomph that gets the rest of this research going. So they make it all worth it. If you have questions, comments, and concerns, I am here to answer those, hopefully.
Thank you so much for that presentation. We'll get questions from the audience.
You talked a lot about the households that are using this and that you look at in this trial. Are there communal applications for soil, like in schools and stuff?
So not for schools. We do have a location in the local market. And then we have an EcoMobile service. So it almost looks like a porta potty, but our toilet is inside. And that's for certain events. I think you can use them for social events or public gatherings and things like that. Yeah.
And kind of a follow-up thing.
Yeah.
The houses that you're putting buckets in, are you also providing like privacy, like somewhere to put it, or just goes in their house?
So the bucket comes with the toilet, and I'm happy to talk more about that. That's another project that I'm working on. But the toilet itself it's heavy, it's made of cement, but you can pick it up and move it to certain parts of your house, or if somebody chooses to have it outside or in their bedroom or in a superstructure, that's all possible. Yeah.
All right, so we have a question from Mark.
Yeah.
Great presentation.
Thank you.
So I was curious, what regulation or restrictions do you face for land application? Is there, you know, a helmet content or something that, you know, it restricts or a holding time for its use?
Yeah, as far as land application, I believe there is somebody in the back room that might be able to answer that better. But as far as like the test that we run, I actually had a similar presentation that I gave to DENEMPA, which I see in the room. And so these are some of the tests that we perform on our compost to make sure that it's up to satisfactory requirements. And I was just, and then DENEPA has guidelines, and these are things that we're researching and making sure that we're staying up to date on. Does that answer your question?
Oh, yeah, is it used for crops or is it, you know, I just didn't know what the primary end use.
Yeah, for the compost, I believe it's used for crops. Yeah.
Great presentation and also kudos. So, you know, one of the things we have to work at is that we are all part of the solution here, right? Every day we generate a commodity, and this life cycle approach to that is truly part of the future of where we go. And the questions are going to scale, right? You dream about a machine that's going to be able to turn. I dream about, you know, Legionella, and so we, you know, together have a nightmare. But so really, so the question is in the communities you've been working in, are they, is there like enthusiasm, or say this is, you know, not what we want? And how would you get this to scale in a way that could really push it, you know, to households beyond your, what are the next steps?
Ooh, that is a good question. And like I said, there are some people in this room that focus on that area in particular.
Yeah, but you're there.
I am here. The microphone? No. But yeah, no, I think, and And team, correct me if I'm wrong, but we try to target communities with the need for sanitation, but also have a dense urban setting where we can collect efficiently. And we also have like a great sales team that does marketing, and we call and we take care of our customers and work on those things as far as payments and customer retention. And like I said, there are some great studies that we've been doing on how we can expand in that area.
And if you can do it in Haiti, what we heard earlier today about fuel and all that, this can go across many, many areas. So kudos.
Yeah, thank you.
Hey, Patrick, good,
Matthew.
nice presentation.
Thank you.
I had two things. One's a question and second is a comment. First, you talked about yield. You have more yield from the hedgerow process than previous processes. What does that really mean? Where do you have losses from other components, things that go to waste?
That's a great question. I learned a lot about compost and coming to work with soil as well, but actually in the composting process, the volume of the initial pile reduces substantially as it goes through this transformation. Yeah, does that answer your question? Or are you more curious on how we get that number?
It's more efficient essentially.
Yeah.
than hedgerow. And the second, also on efficiency, you talked about the fact that the new process is more cost efficient, and you had sort of a negative, it needs more labor. But isn't that kind of from a systems approach, a win-win? You employ more people towards a good goal, and it's cheaper for the end users?
Yes, so is that your comment? That's not really a question. I agree with you. Yeah, that's pretty fantastic. Yeah, and as we're looking to scale, this is such a good problem to have. We can keep our current workforce busy, but as we go up, we can be more efficient and employ more people. That's kind of the beauty of it.
Appreciate it. Thanks.
Yeah, thank you.
I wanted to know how this, well, thank you for the presentation,
Thank
very
you.
good. How the social components fit with the technology. We have experience in Haiti, Habitat for Humanity, and like 6 years ago, we have to approach to the generate compost. But how the human waste is managed in the household level was critical. And this is important to complain or to complete the analysis, taking in consideration social process. My comment.
What was the question? Okay. Thank you.
Sorry, can I just have one quick question?
Yeah, of course.
I actually have two, but I'll talk to you later.
Sure.
Is the cost structure and cost model, is there a point where you could pay someone to poop? Like you could basically be paying the individual for their container? Yeah. I think that would mean a lot to scale up compared to having them actually for the container itself.
That is a dream, that not one that I personally dream about. I think if that were the case, we'd be doing that here. I'd be pooping in a lot of other buckets. For us at Soil, our primary goal is safe sanitation. And so while we hope to recover some costs, it's not a perfect cycle. My poop does not produce more money than it makes. So we have some cost recovery, but ultimately we do spend more money on providing safe sanitation. So, yeah.
If you want to Google phosphorus and see how the depletion of phosphorus worldwide, and that we are all a commodity, and that actually wastewater utilities be paying us to provide them with the commodity.
Yeah.
All right.
Thank you.
So, for the 5 years I've tried to moderate, I've always finished on time. I thought I would ask a question as well. I did my PhD and focused on composting human waste, and I had some kind of quick reactions to the presentation that I think you should take into consideration. That the composting time varies depending on the waste you co-compost it with. 2, you used E. coli as an indicator first, but in my study, actually, I found that Enterococcus and Ascaris actually, were really present even when E. coli was already gone and Salmonella. And also monitoring, there's a lot of things you have to consider to make this viable. But that said, it was a great work, great presentation. Thank you so much. And thank you so much, everyone, for being here on this session. It's been a pleasure to have you.
Very